Hey, welcome back everybody. Moving on to section 6.2, which is titled Multiplying and Dividing Radical Expressions. And remember, radical in math is a word that refers to roots, like square root, or as we've seen, third root or fourth root. Multiplying and dividing them. I'm going to pretty much fly through this and I'm only going to be emphasizing certain things to really care about right now in our situation and the reduced time that we have. But I'll at least skim through everything, right? So you can kind of look at it as you see fit. But look, you should be aware of this, for months and months now, maybe even years, that you can multiply square roots together. Like you can, if you had the square root of 2 times the square root of 8, you can do that. You can say that's the square root of 16. So once again, square root of 2 times the square root of 8, you can say is the square root of 16. So roots, as long as they're the same kind, like that's why the n and the n here have to match. So you've known for years you can multiply square roots together. Well, you can also multiply third roots together and fourth roots together. So this right here would end up being the third root of -8, which you can say is just -2. And this would be the fourth root of 20, which I don't think you can do anything with. Can that simplify? I don't think so. And these two wouldn't even be able to multiply together. And then there's the simplifying, which I'm not going to really get into that much. I mean, it's similar to simplifying a square root like you've been doing for hopefully at least months, if not years. But basically, sorry, but skip. And multiplying first and then simplifying. Again, skip. I mean, also you can divide. Like you should have known that for pretty much years, that you can do the square root of 20 divided by the square root of 5, and you're allowed to say that's the square root of 4. But so that's also a thing as long as it's the same type of root. But again, for the most part, I'm just kind of skipping this stuff. And this, people, is what I really want to emphasize. And I'm going to pick this type of problem to focus on in section 6-2. And the directions for this say, rationalize the denominator. What color will this be? Green. So rationalize the denominator. Now, some context here. From here on out, basically, like in your math career, I don't know about geometry so much because that's so much its own thing. But for the most part, from here on out, it's going to be a thing that your final answers to problems, to a lot of problems, your final answer is not really allowed, quote unquote, to have roots in the denominator. Okay? Like it's just, it's kind of like one of those conventions where, your final answer is supposed to be simplified. I know this is kind of a like a basic example for comparison, but you're not really supposed to have your final answer be a fraction like 4/6. You know what I mean? Like think about a multiple choice exam. you know, and you get a final answer of 4 over 6, you're not going to see 4 over 6 in one of the choices. You're going to see, that same value of an answer, but you're going to see it simplified. You're going to see 4 over 6. You're not going to see that. You're going to see 2 over 3, 2/3. You know what I mean? So final answers need to be simplified. And this is just kind of like along those same lines. You're not really supposed to have a square root, for example, in your denominator. So here's what we do. Now, I know there's, a few examples here. I'm going to write out, like, using my mouse skills, example D. Let's start with example D. What if you had, for example, like 3 over the square root of 2? Okay? And you were supposed to rationalize this denominator. Now, don't get confused by the fancy words. Just, you can't, like, remember how the word rational is like the opposite of irrational? And you also got to remember that when you talk about irrational numbers, you're talking about like square roots or roots. You're talking about decimals that go on forever and never repeat a pattern. And most of those examples that you, like if you had to list a bunch of irrational numbers, most of your examples would pretty much involve square roots, like the square root of 2, the square root of 3, the square root of 5, the square root of 7, the square root of 6. I mean, sorry for skipping that, but you know what I mean? So the word rationalize is like a verb that pretty much means take this denominator that's irrational right now and make it rational. So clean up the square root. Like let's rewrite this fraction without any roots. It's for the most part it's going to be square roots in the denominator. So here's what we do. We're going to multiply, like we've often done over the years. Let's multiply this fraction by something that's essentially 1, meaning this. Multiply something to the bottom and multiply that same thing to the top. You're allowed to do that. You're allowed to multiply something to the denominator of a fraction as long as you multiply the same thing to the numerator of that fraction. Because, again, you're essentially multiplying by 1. Because imagine if you multiplied this fraction by 5 and 5. So you're multiplying the fraction by 5 over 5. Well, what's 5 over 5? That's just 1. So in actuality, you're just multiplying this fraction by 1, which is not going to change it, right? So that is why you're allowed to do it. Anyway, so getting back on track here. I mean, I know I was talking about the theory there and stuff, but so here we go. Here's our main objective here. Cutting to the chase. So what could we multiply to the square root of 2 and it wouldn't be a square root anymore? Pause the video if you want to think about it, because here I go. Multiplying by the square root of 2 will work. Because think about what the square root of 2 times the square root of 2 is. It's the square root of 4. But the square root of 4 is just 2. So try to get that filtered into your brain, your memory, ASAP. That you can do this. That you can do like the square root of 2 times the square root of 2, and it just becomes 2. Or the square root of 6 times the square root of 6 is just going to be 6. Or the square root of 3 times the square root of 3 will just end up being 3. Root 5 times root 5 will just get you 5. Root 11 times root 11 will just be 11. I think you get the idea. So the bottom here, that's like the worst equal sign ever. I don't know if you've heard me say this on any of these videos, but with your mouse, try it sometime. Drawing a horizontal line or a vertical line is really tough with your mouse. Told you. So the So root 2 times root 2, like I said, is really root 4, but that's just 2. And then the top, well, 3 times root 2 is just going to be, well, to put it frankly, 3 times root 2. You cannot mix these. You can't do like a regular number times a square root, so it's just going to become... So that's the answer. I know it might be weird at first, but this is your final answer. This is what it means to rationalize the denominator. You end up with this. So in other words, people, maybe your hypocrite, warnings are going off in your head because apparently the numerator is allowed to have a irrational, thing going on, like a square root. It's allowed to have square roots in the numerator, but you're not allowed to have square roots in the denominator. Yeah, that's kind of the way it goes. I'm going to clear up some space here for example A. So that got us started. Now, again, this is the type of example I'm going to care the most about. But, let me just kind of run through this stuff. If you have a variable involved, you can do this. Jeez. Oh my God. I have to redo at least some of that. What the heck? Oh. Makes you wonder why I can't take oh my God. Why I can't take 2 seconds and access the horizontal line tool like I did in that green line. Alright, so anyway. What could you multiply by to... Now, you're probably thinking, let's multiply it by 7x to the third. Okay? And you're not wrong. You're not wrong at all. In fact, that's what I'm going to do here. Let's just multiply by pretty much itself. Because I know then that this square root of 7x cubed times this square root of 7x cubed is just going to end up being 7x cubed. Alright? Because think about it. The 7 times 7 is 49, so it's going to be the square root of 49. And then x to the third times x to the third is x to the sixth. And the square root of x to the sixth is actually x to the third. Let's just finish this off. The top would become 2x times that square root because they're not really going to mix. And then I'm just going to say that we're done here, even though, look at this. This x and this x to the third would really simplify, and you should make a mental note of that. You should be aware of that, okay? That technically, I'm going to stop here because I'm sick of writing with my mouse. But technically, the x and the x to the third would reduce, okay? Now, another thing, just to kind of tickle your brain a little bit. We didn't really need to multiply by the root of 7x to the third. Think about it. I didn't need to make this into x to the sixth. All I really needed to make it into was x to the fourth. If I could just multiply by x to make this 7x to make it x to the fourth, then I would have been able to take the square root of it. So you don't necessarily like over here, we can multiply, it's the third root. I'm just going to skip that one. I don't want to muddy the waters too much here in this distance learning environment. In fact, in part C for this video, I'm just going to change it. Okay. In fact, let's make this into a 5. So as you're writing this down, okay, and you know what? Let me do something else. Let's see here. What could I do with this? Hold on. Let's make it an 8. I just want to make a point, okay? So ready? Here we go. Now we're good. So what could I multiply to this? Now, we could totally multiply top and bottom by the square root of 8x to the fifth. We could totally do that. All right? But do I need to make this into a 64 for it to be like a perfect square? You know, like all you need to do is get an answer that you can actually take the square root of. You know what I mean? So like what if I just multiplied by 2? Because wouldn't that make it a 16, which you could then take the square root of? And then instead of multiplying by x to the fifth, what if I just multiplied by x? You know? Like that would get the job done. See, again, now I don't want to confuse you. If you just want to keep it very, 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 very simple and just multiply by the exact same thing, the square root of 8x to the fifth, that will work. Okay, but I'm just saying the top would become 14x squared. Then the bottom would become the square root of 16x to the sixth. And then please notice that we can't take the square root of 14 nicely, but we can take the square root of x squared, and that's just going to be x. And you know, don't worry about absolute value. We're not worrying about that. You know. And then down here, like, what's the square root of 16x to the sixth? Well, wouldn't that be 4x to the third? And then, of course, these would even cancel with each other. I mean, so anyway, the homework is just going to be like, I think, for the most part, real basic, you know, rationalizing the denominator, okay? Because most of the problems you're going to see in your life is just going to be like, hey, you have a denominator of like the square root of 2, or the square root of 5, or the square root of 7, you know what I mean? And you just have to, and then again, feel free to multiply by the exact same square root. Do that. You know what? Let's throw in example E, just for the heck of it. You know what I mean? Example E, what if it was like 5 over 3 root 7? Okay, so let's get this out of the way. Just real quick, could you multiply top and bottom by 3 root 7? Yeah, you know, but you don't really have to. In this situation, all you really got to do is multiply top and bottom by root 7. Okay. Now, if you were multiplying by 3 root 7, you would end up with like the 3 times 3, which is 9, and then the root 7 times the root 7, which would be a 7. So you'd end up with like 9 times 7, which is 63. But here, keeping it more simple, just kind of doing the minimum, all you got to do is multiply by root 7. So the 3 is just there, and then the root 7 times root 7, that will just be 7. And so your final denominator is going to be 21. And the top here would just be 5 root 7. So your final answer here would be 5 root 7 over 21. And then you'd be done. Okay? So I'm going to try to keep the homework as basic as possible. Feel free to let me know if you're having any problems, okay?